All right, greetings everyone. Welcome to the Pre-Req video for section 2.5. Just a few things I want to go over prior to jumping into that material. So the first thing that we need to talk about is isolating an unknown term or variable. And we've done a little bit of this already, but just want to review some. Okay, and I know there's a slew of problems here, and if we were all together in class, we'd go over all of these, but since this isn't a video, I'm only going to go over some of them. So I'm going to go over this one, first one here, the third one, and then this last one. Okay. So looking at the first one there, the 4x minus 5 equals 7. Well, we've done quite a bit of this already, actually. This is just solving a linear equation. And in order to do this, we need to isolate the x term here. So to do that, we start by adding 5 to both sides. Okay, and we do that, these can cancel out, and we're left with 4x equals 7 plus 5 is 12. Divide by 4, and then we end up with x equals 3 in this case, right? And boom, we've got that. Okay, and remember that when you're doing this, you're kind of doing order of operations in reverse, right? So rather than dealing with the multiplication first, we dealt with the subtraction and then dealt with the multiplication. All right, let's look at the next one. So the 5 over s plus 7 equals negative 13. Okay, now here, all right, we again need to isolate the s, which means we need to first isolate the term with the s, which is the 5 over s. So we'll start that by subtracting 7 from both sides. Okay, when we do that, we end up with 5 over s equals negative 13 minus 7 is negative 20. And we still need to isolate this s somehow, but notice that in this case, the s is in the denominator. So in order to get it out of the denominator, well, how will we do that? Right, we'll multiply by s on both sides. Okay, so when we do that, the s's here will cancel. You're just left with the 5 on the left-hand side. And we have negative 20 times s on the right-hand side, and I'm out of room, so I'm just going to have to rewrite that here. So we would have 5 equals negative 20s, and then now that negative 20 is being multiplied by the s, so to get rid of it, we do the opposite, which is divide by negative 20. And when we do that, these cancel. We're left with s equals and 5 over negative 20. Careful, that is not negative 4. If it was negative 20 over 5, it would be negative 4. But in that, we can reduce both of these by 5. And so we end up with negative 1/4 there as the value for s. All right, now what about the last one? Here we have 5 and then a happy face plus 13 equals negative 7. And the purpose of this is to see that even though in this case it's not a variable, right? It's not a letter. The unknown thing is still something we can isolate and solve for, right? So we have a 5 times a smiley face plus 13 equals negative 7. And even though it's a smiley face this time, we can still go through the same process. So we can subtract 13 here on both sides. We end up with 5 times smiley face equals, these will cancel, negative 7 minus 13 is negative 20. And then divide by 5 on both sides. And so we get smiley face equals negative 4 in this case. All right. So again, the moral of the story here on this one is that regardless of what the unknown thing is, in this case it was a smiley face, we can still isolate it, okay, using all the similar techniques we've used in the past. All right. So So one more thing then. Let's talk about absolute values, okay? And in this case, we've got 3 absolute value equations here. And what we need to think about is what could be inside of the absolute value, or what could the variable or unknown thing be in each case. So let's start with the top one. Absolute value of x equals 7. And we first maybe have to talk about what does absolute value mean or measure, right? We're saying the absolute value of x equals 7, of something equals 7 there, right? What are we really saying? Well, recall that absolute value is something that measures distance from 0, right? And so what absolute value of x equals 7 is really asking us to figure out is what could x be, where x is a number whose distance from 0 is 7. Well, hopefully you can see from the picture I just drew here that 7 is 7 units from 0, right? So x here could be 7. But is that the only thing x could be? No, it couldn't, right? Because it could also be something the other direction. Okay, it could be -7. That is also 7 units from 0. So here we have x equals 7 and x equals -7. Okay, so those are the 2 possibilities for what x is there. All right. Well, in a similar fashion, for the next one, we have absolute value of smiley face equals 57. And even though we're using a smiley face here, right, the idea is still the same, is that the absolute, or the smiley face has to represent 2 things whose distance from 0 is 57. Well, in this case, 57 fits that mold, right? But then -57 also fits that mold, right? Both of those things are 57 units from 0. So they both are what represent things that the smiley face could be. All right. And then the last thing here, absolute value of t minus 1 equals 13. Now in this case, right, we have an expression with more than just a variable inside the absolute value. We have absolute value of t minus 7 equals 13. But really, right, even though it's like that, we could really think of this as absolute value of smiley face equals 13, where in this case, the smiley face is taking the place of t minus 1. And then thinking about what we just talked about, right, in this case, the smiley face could be 2 different things, right? The smiley face could be positive 13, but it could also be negative 13, because the absolute value of something we're saying is 13. But in this case, right, the smiley face is not what we started with. We started with t minus 1. So what we're really saying is that t minus 1 equals positive 13, and t minus 1 equals negative 13. We can solve both of those. And notice when we do that, we end up with t equals 14. And add in 1 here, we end up with t equals -12. Okay, so in this case, the 2 things that t could be are 14, positive 14, and -12. Okay? Now, one little word of caution. When you have something like this, where it's the absolute value of an expression equals a number, and you're trying to solve for a missing variable or something, your answers will not always be 1 positive and 1 negative. Okay, sometimes they could both be positive, and sometimes they could both be negative. So notice here we got 1 positive answer and 1 negative one. That's not always the case. Now, it will always be the case that your expression there can be set up as 2 separate equations, one that's positive and one that's a negative, equal to a negative. So here we have equal to positive 13 and equal to negative 13. But when you solve down for your variable, you might not only end up with just a positive and just a negative. So keep that in mind. All right, that's all for now. Thank you for watching.